I'd like to walk through an example cartographic model here for a study area in western Placer County, California. It's an area that's experienced rapid growth really for the last 20 or 30 years. And in this case, we have a snapshot of data from the early 2000s on a fake analysis of what you might do to identify park lands. Now, there's a lot more that goes into analysis for this kind of problem, but this is representative of something that a parks department might do as a first pass to identify parcels of interest with which to enter in a fuller or deeper investigation. So this is the Great Central Valley in California. The mountains are here, the Sierra Nevada Mountains to the east, and San Francisco and the ocean is to the west. And this area for potential parks has a number of criteria that have been developed. One is that it has to be in western Placer County. They want areas that are within 150 meters of a stream, within 300 meters of wetlands, soils that support vernal pools and have natural vegetation, less than 3 kilometers from urban areas, and a number of other things here. Now, you have to convert these to specific criteria. So we'll have to go through identifying data and then making these criteria operational for the application of GIS tools, of spatial analysis tools in a multi-step process. So first, to identify the data we need. If you look through the list, they get named: wetlands, streams, soils, study area, city limits, natural vegetation. We have to define or determine where to get these, right? You remember Chapter 7. So the boundary area you can get from a county map or county data, but the MRLC or NLCD or the National Agricultural Statistical Service data for land cover, population data from census, soil survey data, and all the others that we went over before. You always want to get the latest and greatest and most appropriate data for your study area. So this will change depending on what resources are available locally, at the state level, or nationally. I've identified these. I want to turn these vague statements into a set of operations, and it helps if we know what kind of selections or what kind of operations represent the intent. So we have to ask questions. These are within the study area. Now, the original requirement said that they were study sites within 150 meters of stream, but you have to ask, does that mean they have to be any site within 150 meters of stream, or this plus the other requirements? It's whether they're restrictive and it's an and requirement, or whether it alone, being close to stream, makes it a likely area to look. And so you have to decide which of these are or and which of these are and. And in questioning or in reviewing the criteria, you get that information. So in this case, these have been converted to any or types. So any soil with vernal pools, doesn't matter where else it is, those are fine. But then there are the must, that we're going to apply a set of things that have to hold true on top of all these. So all these get submitted to expand the area, and then these restrict them. So we have to decide which are the ors and which are the musts or ands, and we sort those. So we've gone through that. Now, once that is set up, we can get clues to how we want to set up our analysis once you've decided what are these any or criteria. So we're going to basically do an overlay or a union that incorporates all these areas that are near wetlands and near streams and soils. So these will add, so it'll be this, I should say, or soils or streams. So we'll build an area with these, with ors, making an inclusive area, then whittle it down with these, right, with the musts. So that kind of gives us a notion of how we'll set up the data analysis for the identified data and then the identified criteria. There's additional information here. Parcels have to be unsplit by major roads. So these will be selections, right? Parcels, we have to calculate area and select them. And we have to calculate travel time sort of to figure out how to rank them. So these are selections after we've done all the geographic combinations. Generally, you do the selections towards the end, although that doesn't have to be if they're global selections. And generally, you do the ors first and then the ands. But it doesn't matter. You can do them sort of different ways. It just tends to work out that you can get by with fewer steps if you do ors, then ands, and then selects. if they're global selects and global ands and ors. So here's the dratted flowchart. And one of the things about the flowchart you can see is that each of these criteria really corresponds to starting with the data set and then applying it, and then building all those ors or ands together with unions or clips or other things along the way. So in a sense, if we look at how we lay out the ors versus the ands versus the selects, we have a roadmap, right? Ors first, and then all these are the ands to clip and restrict, and then there's these selections at the end. So stepping into the flowchart, you can see the streams and wetlands or soils, those three things that amplified an area. Will subset those based on the criteria and buffer because they're distance-related criteria, and then we'll union those, and this will give us all the potential areas. Some of these will be restricted then later on because they're outside our study area or they have too high a population density, but this gives us a big area. Now graphically, we can look at it like, okay, the NHD flow lines, and we need to subset these NHD flow lines before we do the buffering on them. And you might ask, why subset? Well, think, buffering is a time-intensive process, and these were delivered in this NHD data set that's quite large. And so by clipping, I can reduce my calculation load substantially. And if I don't have a super fast computer relative to the data, that's something that's worthwhile. The thing is, you have to be careful how you clip or the boundary for which you clip, because in buffer-related analyses, you can run into problems. So there may be areas here at the edge of our study area where you have a stream that is outside the clip for the study area, but we have areas inside that buffer distance. This may be less than the 300 meters we require, or 500 meters, or whatever the buffer distance might be. So when you clip, you should look globally at what you're buffering and make sure that you, if you clip inclusively, that is, expand the clip boundary by the buffer distance at least that you're going to use, clip that, and then buffer again. Otherwise, you might get pieces like this where we wouldn't build a buffer on this portion of a stream which lies outside of our boundary. So here I've expanded the network that I'm going to buffer and then clipped after I've expanded that network, so I make sure I get all the areas. But I do that buffer then, and here I arrive. And here's what I end up with. So here's the little bit larger area that I buffered on. Okay, so that's the buffer. Soils, where are vernal pools? Well, I have to look to the literature and identify the soil types from the Surgo data set that show what soils have a propensity to have vernal pools. Now, if that information isn't developed, I can't just make it up. I either have to go develop that, I just find somebody who knows something about vernal pool location, or drop that criteria or modify it. Now, in this case, it's been discovered that these durapans, these hard pans, where the rock is cemented at some level, reduces infiltration rate, and so you get a set of conditions that allow vernal pools or these spring ephemeral pools to exist, and there's whole ecosystems of flowers and plants that live around those that are a feature worth saving. So I go to the literature, get the information, gives me the list to select, I select them, and I get a subset. So here are the suitable soils in my study area. So soils, wetlands, and streams. Again, I buffer on the wetlands, selecting the wetlands from the NWI, and here are the potential areas altogether. I can union them and then dissolve. Again, why do I dissolve? Because I don't want to carry these polygons that are all effectively in the same category acceptable. The extra lines make processing slower. And so here's my potential areas clipped within my study area bounds. Well, okay, I've done this part of the flowchart. Now I have to start going to the restricting part, the AND part. So here's the first one, must not be in city limits. I'll get a city limit boundaries. I'll do the select class and dissolve and identify those areas outside, and then I can either erase what's inside, all the potential areas by what's inside the city limits to get the refined areas, or I could do a clip and dissolve or a clip and save. So here we want to clip what's outside. What I'm going to do is I'm going to erase, because it's just one less function. So here I have all the city limit boundaries, and I can erase out of my existing potential areas, those that are inside the city limit boundaries. Again, there are other ways I could do this, but this is quicker in this case and fewer steps. So here I have then my new potential areas with those city limit boundary areas removed. The next step is this and restriction on the land cover must not be in farm or urban land use, or converse must be in natural vegetation. So I could select the natural vegetation and do a clip on that, or I could do a farm and urban and do a race and do that. Here, remember, I go to the NLCD or MRLC or NAS, National Agricultural Statistical Service data, and I get the non-farm, non-urban natural vegetation. So I have to do a recode to get to this. And then I can basically do a raster to vector in the case that I want. And here I'm going to do a median smooth to get rid of this small speckle. We talked about that. I found a 5x5 worked to get rid of a lot of these spurious single cells that were identified. And so now I have all the areas that are in natural vegetation. And I can clip the remaining potential areas with this natural areas because I really just want to use it as a sieve, and it pokes some more holes and gives me then a reduced area. Again, I'm doing the and functions one after another. Again, must be in an area with a low population density, another and, so I'll do the census. You're starting to see a theme here. I'll reclass and dissolve. I'll get the population areas that fit. I'll join a table again, and it provides for all of the tracks the area I want. We want to subset to the study area. So here I do the calculation, and then I can clip, and here I get the areas that are in this population density less than 50. So again, I'm restricting. I always want to look and make sure, yeah, the clip did what I thought it should do. I'm getting these areas with low population density and all the other sides disappearing. So I'm getting rid of this stuff over here when applying that low population density criteria. Finally, I'm getting this land cover. I want areas that are 1 to 3 kilometers from an urban area, not too far and not too close. So I have to do a buffering, and I'm burying some steps in here because there's a couple of buffers I have to do, and then I combine them and I'll clip by that. And so if we look at that in practice, again, skipping a few steps, I'm going to reclass, then I'm going to buffer on those. I'll smooth in this case to get rid of some of the stuff. Then I want to buffer urban areas and condition the road lines. So this is the road lines here, and I want to basically 1 to 3 kilometers of the roads. So here are the areas that are 1 to 3 kilometers from roads. So I get these candidate polygons here, and I need to basically then clip out the existing ones. So here I have the areas that are close to roads, 1 to 3 kilometers from roads, meet all my other criteria, and these are the two, or the set, that are left. So I have these final potential sites here.